Hello guys, welcome back to my channel. Happy Sunday everyone. So in this video, I'm going to demonstrate to you how to detect packet loss using Wireshark. Okay, and before we jump into the practical demonstration part, I would like to add a brief info about what packet loss is in networking. So basically, packet loss is in networking occurs when data packets traveling across a network fails to reach its destination. Okay, this can lead to disruptions in communication as well as causing issues like lag whilst in online gaming or video call freezes all of a sudden, and also causes slow internet browsing. Okay, if I want to give a real life example, right, imagine, let's say you are on a video call with a friend could be anyone. Suddenly the video freezes and you miss part of the conversation. Okay, this happens because some of the data packets carrying the video and audio information were lost in transit, okay, causing a temporary disruption in the call. Okay, and also packet loss can be caused by various factors, guys, including network congestion, faulty routers and hardware, as well as interference in wireless networks. Okay, and it's like sending a letter through the email, but some what you can say, but some letters get lost along the way, leading to incomplete communication. Okay, so have you ever experienced packet loss issues before? And if not, I'm going to show you how this exactly works and how to detect it using Wireshark tool. Okay, Wireshark packet capture tool. So this video is going to be comprehensive, guys, which includes both theoretical and practical explanation. So I would request everyone to wait and watch the entire video and get the most out of it. Thank you. Let's quickly get into the further discussion, guys.
Hey guys, let's quickly jump into the practical demonstration part. But before that, I would just like to add some theoretical part as well. Basically, these are the common Wireshark filters that we will use to detect packet loss in a network. Okay, I have written it down for your awareness and reference in future as well. So the most common ones are above, and last few are a bit uncommon. Okay, so the initial few filters itself would help us find or detect packet loss. Okay, in a network in an easier way. So if you want, like, I can give you just an explanation on what these filters would do, okay, within the Wireshark. So basically, the very first one, which is the most commonly one in use, okay, by any network engineer or a network analyst, whatever professional who is troubleshooting network issues related to congestion, network slowness or lag, etc., will use this filter as the very first way to go about things to identify the possible cause or root cause. Okay, so basically the very first filter, right? These are called as flags, guys. Okay, this particular flag in Wireshark indicates that a packet has been retransmitted, guys. Okay, this typically happens when the sender, as in the source, does not receive an acknowledgement message for the packet that the sender had sent within a certain time frame, guys. This is called as retransmission timeout. And uh, and as you know, like, if I want to give the purpose of this filter, okay, so basically the retransmissions ensure reliable data transfer over TCP communication, okay, by resending lost or corrupted data packets, guys. Okay, and if you ask me what are the common causes for retransmissions, like I said, the most common causes are network congestion or faulty hardwares and routers. Certain software related bugs can cause it, and also network slowness. Okay, and even your bandwidth related issues as well, which comes into play. Okay, so Wireshark can detect all these in the form of flags, okay, denoting retransmissions within a TCP frame. Okay, and if you ask me, like, what this other the second one does, so it clearly goes into checking of packets that have been not captured, as in the whichever segments within a data packet or communication TCP communication has not been captured, it is going to list down that. So I can give you just a brief explanation of what this does. Basically, this is a condition, guys, okay, which matches any TCP segment that Wireshark believes it was lost. Okay, and Wireshark makes this judgment based on sequence numbers, guys, because each data packet gets allocated with a sequential sequence numbers. Okay, and if it sees an acknowledgement for a sequence number that is not recorded or has a record of, it assumes that the corresponding segment was lost, guys. As a result, this filter condition can also help us in detecting packet loss within a network. Okay, and within the Wireshark particularly. Okay, and if you ask me what this third condition or filter would do, so basically, again, this condition matches any duplicate TCP acknowledgements. Basically, duplicate acknowledgements are often a sign of packet loss, guys. So when a receiver sees a gap in the sequence numbers of the packets it's receiving, like for example, I'm sending you 4 chocolate packets, okay, and out of that, if you have received if you have only received a single chocolate packet, 3 chocolate packet you have not received it, what you will do is you will send me an acknowledgement for the received packet, which is number one chocolate packet, and as a result you have not received 234. But how do you communicate to me? It will be like three. You will put up that, you will specify that I have not received the chocolate packet for 234 sequence numbers. Hence I'm not sending you acknowledgement for this, but instead I'm sending you duplicate acknowledgement telling you that I have not received the chocolate packet for the sequence numbers 234. Okay, so hence this will clearly indicate, if there is a duplicate acknowledgement, it clearly indicates that there is a packet loss in the network. Okay, and if it continues to receive packets with higher sequence numbers, okay, then what happens is the acknowledgements are often a sign of a packet loss, guys. So like I said, if it continues to receive packets with higher sequence numbers, so it keeps resending, as in the receiver keeps resending the same acknowledgement number. Hence what happens is the term that is given for continuous duplicate acknowledgements is duplicate ACK. Okay, and this out of order, again, like I said, it's the same scenario, guys. Like what happens is this condition matches any TCP packets that arrive out of order. Like I said, if you have received um, sorry, basically this will be like, again, this particular thing also signifies or indicates or denotes there is a possible packet loss in a network. So basically what happens is the condition matches any TCP packets that arrive out of order. Okay, TCP packets should arrive in the same order when they were sent, as determined by their sequence numbers. If they don't, it could be a sign of network issues like packet loss or routing inconsistencies. Like I said, if let's say I have sent you 4 chocolate packets, okay, by naming them 1 2 3 4, and if you have not received it in the order of 1 2 3 4, and if you are receiving it, let's say 1 2 sorry 1 3 and 4, and you have not received the packet, sorry, the sequence number as in the second packet in the order, in the same order, then it becomes out of order for you, for the receiver. And as a result what happens is again there will be a retransmission happening from the sender to say to properly send the lost packet, as in the out of order packet not receiving the destination as in the receiver. Okay, but this particular filter will also display all the out of order packets, okay, received by the not received by the receiver. Okay, so again, understand the theoretical part would be boring. So if I explain you in a more practical sense, it will make more sense. Okay, so probably what I will do is I will use an existing packet capture, guys. Okay, basically the Wireshark capture is running just now. Quickly open up a browser and keep refreshing these pages here, which is basically delivered to me through content delivery networks like AKMI servers and more content delivery networks out there serving us the web pages. Then what I'm going to do now is I'm just going to go to statistics here and click on conversations, go to TCP communications. And now let's see if there is some big. So basically I did not have much packet captured, guys. The byte size, if you see, it was less. Go to some more pages here. Let's do more browsing here, basically. Probably I will just close and reopen Wireshark, guys. We'll do all from the beginning. And start capturing now for my Wi-Fi network. Okay. Just reload some of the pages here. Let's go to type. I will search my own channel. That's everything. Okay. I think this is my channel here. Just reload these pages here. Okay, and so what I'll do is just go to conversations again, statistics, conversations, TCP. Okay, basically this is my router's IP address, guys. Seems to be source at the moment. Okay, let's do for the first one here. I will just go. It is having 84 packets in total, 84 data packets. I'll just click on apply as filter, select A to B. So we are going to listen to conversation between these two IP addresses here. Okay, on port 443. If I do enter, you can see here the total number of packets displayed just now is 86, guys. Okay, and if we do and TCP dot analysis dot retransmission, if I do, and we don't see anything. So basically, whenever we are troubleshooting a network issue, we have to be specific, guys. Okay, we have to specify a source and destination, or we have to specify uh, two addresses basically. Okay, it could be either one could be a source, either one could be a destination. Okay, vice versa. Okay, so here we are not specifying a source and destination. Instead, we want to listen to conversation between two addresses, two computers, two systems. Okay. However, for these two machines, there is no packet loss here. See here, I applied this filter here. There has been no retransmissions, which means communication is happening smooth and fine, and there has been no retransmissions whatsoever. However, within this entire packet capture, if we just become more generic, in a more generic sense, if I just do this one here, I'm just seeing a couple of packets which are retransmitted. Okay, if we just quantify it, the total packets within the packet capture is 47 42. I mean, it's going to keep changing. That's because my Wireshark capture is still running. And if you just quantify this two packets here, it is 2 divided by 4,800 approximately, which will be 0.000% something. So it's not a significant packet loss at all. However, if I want to show you what is significant packet loss, that's what I'm trying to do now. Not able to reproduce the issue. Let me see if I get some level of some way to tell you there has been a significant packet loss. I will connect my Wi-Fi by disconnecting it and reconnecting it. Maybe that gives some data to work at or to look at. Hopefully it gives us an idea. I'm going to go to conversations again. See if there is some changes here. Okay, you can see here. I think this 20.60 IP address, that's from my router to this address. Probably this is a content delivery network IP address. Let's do IP lookup here. 20.60.194. 20.64. 20.64. Sorry, 60. 20.60. Could be AKMI servers. Let me check which are content delivery network. 194.195. 94.195. If I just okay, so you can see here it's Microsoft data center, guys. Again, it's again content delivery network here. Okay, so if you see the ISP is Microsoft Corporation. So content delivery network could keep changing. Okay, it could be AKMI data centers at times. It could be Microsoft data centers at times. Okay, it depends. Like who is hosting the service. Okay, like for example, I probably did a Facebook.com. Probably it is using Microsoft data centers and even the YouTube ones. So that will keep changing. But however, at least we're getting some data here so that we can work. Probably I will disconnect my Wi-Fi and reconnect. So the first one we saw was a good case, like where we did not see any packet loss at all. There were no packets lost. Okay, the second case that we're just seeing right now by doing a general retransmission filter, we got this right. TCP dot analysis. If we do a retransmission here, I think we just saw a couple of packets. Now you see there are a lot of ones here. Okay, now at least we're seeing there are a lot of you see a couple of spurious retransmissions as well, which could probably indicate a packet loss between source and destination. Okay, so whichever ones, right? Okay, let's say let's pick a conversation, guys. We'll just do one thing here. Go to conversations again. Probably we will have more data to look at. Okay, it's still less only. It's not more. Still in KBs, guys. But at least we're seeing handful amount of free transmissions now. See, there are more. But however, it is the entire packet capture here. But if we have to look into a specific conversation between a source and destination or between two addresses, we have to be specific. That's how we can quantify the amount of packet loss that has happened, that could have happened. Let's pick up two addresses that we see more. These are the Okay, 44.230 has a bit of 44. Yeah, this one. Still, it is only in bytes, guys. Just apply this as filter. Even then, it's not significant, guys. Total, you see here, total packets. You see the entire packet, which is 6. If I do an and TCP dot analysis dot retransmission, all we see is 4 packets. But again, this is significant, guys. If I remove this filter here, see this is a significant packet loss here. Okay, total packets that we are seeing is 6. Okay, out of 6 packets, if I do and just go to TCP dot analysis dot retransmission, we see 4. If I just quantify it, I do 4 divided by 6 here. It's almost 66% packet loss, guys, for this particular conversation. So this is significant. This is what I called. If you see significant amount of packet loss, then I mean, a significant amount of packets having retransmission, it could potentially indicate there is a packet loss here between these two IP addresses. Okay, this is the best case I could have shared with you. So what I did was I was looking into the TCP conversation between these two IPs here. We totally see 6 packets here for these two IP addresses. Okay, we can right away count here. It's easy for the naked eye to count 1, 2, 3, 4, 5, 6, which is also displayed here. Total 6 packets. Out of the 6, we see 4 retransmissions here. You can see here. And since it is like in case if there were more, we obviously had to apply this filter here. TCP analysis dot retransmission. It will show us how much packets have been retransmitted, which is 4. So if you want to quantify that in percentage, it is simple. Packets that were lost divided by the total number of packets. Okay, like I showed before, 4 divided by 6, which is equal to 66%. Like it is significant in terms of purely in terms of looking into from a networking angle, it is a significant percentage, which is 66%. Okay, of packet loss for this for the TCP streams for these IP addresses alone. Okay, because we were more specific, we wanted to look into specific communications between a source and destination, vice versa, destination and source. We found out that there has been 4 packets that were retransmitted out of 6 packets in altogether. So that indicates potential packet loss. Okay, however, which could be due to a lot of factors, like I said, due to network congestion. Okay, due to faulty hardware in the form of faulty routers, faulty switches, etc. And it could also be issues related to your network slowness. Okay, and even it could be due to what do you call it, network bandwidth. In case if you have poor bandwidth, you will experience these issues. Okay,